just doing that stuff is great. I actually used to teach classes and objects a little bit later in the course because they're so complicated for people. But what did you learn? Well, a class is like a blueprint, and inside of that class, you list instance variables. That's like the data. And then once you have a class, then you can create objects from that class. And objects you can think of as just nouns, like the stuff around you. You could write a class that describes a table. It might not be very interesting, but it might have instance variables like an int for the number of legs, a string for the color, a string for the material it's built with, etc. Then after that, you learned about constructors. Constructors are how you actually create objects. Constructors always start with public and then the name of the class. So if you're making a table class, it would be public table, and so on and so forth. Those are like the object factories. They allow you to create those nouns, the instances of the class. And usually with constructors, we specify values for some of the instance variables. Now, going off of what you learned last week, and you also talked about overloading methods, it's really important that obviously you do those first. And seeing the people that are here, I know you guys have done those activities already, so great job, keep it up. In 2.5, you're looking at calling a void method with parameters. If you don't know what a parameter is, remember it's basically the data a method expects, the values that go inside of the parentheses. It's the data that a method needs to do its job. You've actually seen this a little bit in some of the constructors in 2.1 through 2.4, because the constructor for the pizza class, for example, required a string representing the type, a string representing the toppings, and then an int representing the size of the pizza. Those were parameters. So when you said like veggie, mushrooms, olives, whatever, and then 10, that was calling a method and sending in parameters. You guys just didn't even know it. You were basically already doing 2.5. So my notes on 2.5, first, look at the method header, the very first line of the method. It often looks something like this one here that I have highlighted on my screen. There's a lot of information in that method header. Sometimes you can think of a method header as a contract, or it's like the cliff notes of a method. What does the method do? That would be the method name. And then what does the method expect? That would be the parameters in the parentheses. So the way that you call a method, which again you folks did in 2.4, is you do the name of your object dot the name of the method you want to call on that object, and then any required parameters go in the parentheses. So as an example, if I have a method that looks like this, public void print third leg, thinking of like a triangle class where you're trying to figure out what the third leg of the triangle is, you maybe have 3 parameters: a double representing the value for leg 1, a double representing the value for leg 2, and a Boolean telling you whether or not it's a right triangle, because calculating the third leg is different depending on whether it's a right triangle or not. If it's a right triangle, obviously you can just use the Pythagorean theorem. If it's not a right triangle, you'd have to use, what is it? The one with the semi-perimeter, Heron's formula, that's the one. You guys familiar with Heron's formula? Big Heron fans out there? H-E-R-O-N, Heron's formula? It's like you got to find the semi-perimeter, and then I guess that's the area. I'm making a fool of myself. Let's just keep talking here. So anyways, here's a method that requires a double, and then a Boolean. So if I want to call it, I do a name of an object. Maybe I have an object called triangle1. Then I do the name of the method. This is wrong. Print third leg, excuse me. And then same down here, I have to change this to print third leg. And since the method requires a double, and then a Boolean, I need to pass in a double, and then a Boolean. That would be the correct call to print third leg. However, in the second example down here, you see I've done Boolean, double. I actually got a lot of emails from students last week that were having problems on the pizza problem because they had goofed around with the order that they were sending the parameters in. If the method says it needs a double, and then a Boolean, you need to send those values in that order. So a double, Boolean would be correct. Boolean, double would not work. It would not find a method that has that signature. what you're doing when you call a method and you put stuff in the parentheses, you actually put values in there, is you're sending values to the parameters. Essentially, these parameters, leg1, leg2, is right triangle, they're just placeholders. It's like in math class, when you say f of x, you don't know what x is yet, it's just a variable, and that way you can use it when you're writing your equations out in math class, like x squared plus 3x plus 2 or something like that. But then when you actually say f of 3, you can then evaluate the method. You put in 3 for x. It's like substitution, if you remember that from math class. So when I say triangle1 dot print third leg, 3.0, 4.0, true, this 3.0 gets sent in for leg 1, this 4.0 gets sent in for leg 2, and this true gets sent in for is right triangle. So you have to make sure you fulfill the contract essentially in the method header. If the method requires double, double Boolean, you need to send it double, double Boolean. And so that's what methods with parameters look like. Again, you do the name of the object, dot the name of the method, and then you send any values that are required in the order that they're required in. If you don't put them in the correct order, like my second example, Java doesn't know that, and it's going to say, I can't find a method that wants a Boolean double double. And so it'll just give you an error and crap out on you, essentially. It won't compile. So that's calling a void method with parameters. If you think of a question, go ahead and throw it in the chat. I'll give you a minute here to think of questions if you got them. While you're thinking of questions, I hope everybody maybe is enjoying the weather. Yesterday was a pretty beautiful day, a little breezy. Went for a little jog outside. This morning was beautiful. It was like 38 degrees, but felt like 50 degrees, which is running weather. So went for a little jog this morning. Okay, I don't see any questions, so I'm going to stop filling dead air here, and I'm going to, hopefully I didn't miss a question. Alt-H. That's not what I want to do. Okay. Okay. I didn't miss it. Okay. Cool. All right. I'm going to move on to 2.6 then. In 2.6, you're calling a non-void method. So again, these all build on each other. It's like math class. You have to learn the stuff early in the section until you can get the stuff later in the section. It's scaffolding, is what we call it in the education biz. So calling a non-void method. Here's what's going on with the non-void method. So far, we've been calling methods that just print stuff, like print greeting, or if you remember that section where you were calling English, Spanish, French, and it was giving you a greeting and stuff like that. Those methods just put stuff on the screen, but they don't really give you a value back and forth. Essentially, what we look at in 2.5 is we're giving inputs to a method. Well, what if we also want to take something back from a method or have the method give something back to us? Just like in 2.5 where we give values, we essentially give inputs. In 2.6, we're looking at returning inputs. The method will actually give something back when it's called. So if you've joined me on any of these calls, you know I kind of think of methods like a assembly line. And so now, after a method's done with something, it's going to pass some data back to wherever it was called from, typically the main method. So I wrote, just as methods have inputs, parameters, they can also have outputs. And I'm not talking about printing on the screen. We've already looked at that. I'm talking they actually give you back a value that you can then do some computation with, etc. The type of value that must be returned goes in the method header. So it's all, the first line of your method is always public, followed by the return type, and then the method name. If you look back at 2.5, 2.4, most of the methods look like this example: public void, print third leg. They're all public void, public void, public void, because they're just printing stuff. They're not actually returning any data. What you're going to see in 2.6 now is it might say public double, public Boolean, public string, something like that. And that means that the method is actually going to give data back after it's done its job. So to actually do that, you're going to see something called a return statement. A return statement always goes at the bottom of the method, and it always ends the method. And basically, it's what you're giving back once you're called. So As soon as you see a return in a method, you can't write anything under it because it just ends the method right there. Nothing goes after it. It's like it kicks it out. It's like hitting the ejector button on a fighter jet. I only know what I've seen in movies. I don't know. So what do you actually do with the value that you get back? Well, there's two things that you can do. So let's say that there is, I should put this in my example here. Let's say that there is a public class rectangle, something like that, and then inside of it has a method like public double area, where it calculates the area. Here, I can even fill out this class a little bit further. Maybe I'll give it an instance variable for the length, and I'll give it an instance variable for the width, something like that. Well, in the area method, we know to calculate the area, you would do length times width, and then at the end of this method, you can actually return that value. And so what would actually happen here is if I want to call this area method, notice there's no print statements in it, and it also looks a little bit different. Instead of saying public void area, it says public double. What's going to happen is when I call this method, it gives me back a value, a double value representing the area. So what do I do with that value then? Well, there's two options. You could just print it out immediately, but that wouldn't store it. So if I want to call it, again, maybe I have an object called rectangle1. I say the name of the object, rectangle1 dot, the name of the method, area. Then I put parentheses and put in any required values. If you look at area here, it's got nothing in the parentheses, so I leave my parentheses blank. Now, if I just put this line all by itself without a print statement around it, I would see nothing on my screen because rectangle1.area is giving back the area. This essentially is a double value representing whatever the area of that rectangle is. And so I could print it out. The other thing you might want to do is store it in a variable for later use. So that's part B here that I have. And so in this example, I declare a variable named area, and then I call the method rectangle1.area, and whatever it returns, now I'm going to store it inside of that variable. So 2.5 and 2.6 are very closely linked together. They're basically two sides of a coin. In 2.5, you're giving data to a method so that it can use it in its calculations and stuff by sending in parameters. In 2.6, you're calling a method that then sends back data to you. So essentially, you can think of 2.5 as the inputs for a method is what you're looking at. In 2.6, you're looking at the outputs. What can a method give back to you? And again, the big changes between 2.5 and 2.6 is you'll see that the method header has a type now. It could be double, it could be Boolean, it could be string, where it's actually going to give you a value back instead of just putting something on the screen that you can't do anything with. And so what do you want to do with it? You either want to print or store it in a variable. So that's 2.6 in a nutshell. I know it can take a while to formulate questions, so I'll give you a second. While you're doing that, anybody watch any new good shows? I just watched all of Too Hot to Handle on Netflix. I binged it in like 3 days. It's trash TV. I don't recommend it. I can't recommend it, but it is on Netflix. It's a terrible show. One of those reality shows, the dating shows, pretty bad. I'm getting caught up on Doctor Who, if anybody's a Doctor Who fan. What's her name? Jodie Whittaker. Getting caught up on those. Just finished the 2-part season premiere, so I've got some work to do there. Okay, looks like no questions on 2.5 and 2.6. So again, 2.5 inputs for a method, 2.6 outputs, values coming out of a method. Essentially, 2.5 is like sending an x value to a f of x function. 2.6 is like evaluating and returning f of x, essentially. Plug and chug, substitution, whatever you want to call it. The last section that you're looking at today, this week, is on strings, doing stuff with strings. What are strings again? They're just a sequence of characters we put in quotes. Whatever we type in inside of the quotes will show up exactly as we've typed them in. It's another type of variable. You looked at ints, you looked at doubles, you looked at booleans. Strings, though, are a little bit fancy, and maybe you could have kind of recognized that because strings have a capital in their type instead of int, which is lowercase I int, lowercase d double, lowercase b boolean. String is a capital S because it's actually an object that you're creating. Ints, doubles, booleans, those are simple types of variables. We call them primitives. Strings you can do more stuff with. Strings are a little bit more interesting. So we actually make string objects, and that's how they kind of fit into this section, is because this section is all about dealing with objects, and strings are probably the most common object that you deal with as a computer programmer. So they teach you a few things about strings in 2.7. The first thing they teach you is what's called the escape characters. If you insert any of these strings like \n or \t or \/ into a string, there'll be something special that comes out. There are these special characters called escape characters. I thought maybe I could do a quick demonstration of them. Can you can still see what I'm doing? Can you see Code HS right now that I pulled up? Oh, thank you. Thank you. I appreciate your response. So let me show you something. If I do, here's an example of this escape character. If I do hello everybody inside of quotes like that, and I go ahead and run my code, it's going to print out hello everybody. Now, one of the special escape characters is \n. If you put a \n in, even if it's just like jammed inside of another string, like I've got it here, it's going to start a new line wherever it sees the \n. So now this looks like hello, new line, everybody. There's other ones that you can put in. If you put a \t anywhere inside of your string, that adds a tab, which is really good for formatting if you're trying to print out a bunch of data that looks nice, something like that. \t will add a tab. You guys know, like when you're indenting a paper for English or AP US history, when you have to write your 6 essays a day or whatever, \t is a tab, an indentation essentially. And so there's that. And then lastly, since you do all of these special characters by starting with a \, well, what if you want a single \? Then you put \. Why is that? Well, essentially \/ is a special character. You put \/ to indicate, hey, this is a special character. It's the \. And so those are in there. Some things that my students goof up often when they're looking at these escape characters, they'll put /, and that'll give you an error. Something like, well, actually, it might not give you an error, just say /t. It doesn't do what you're looking for there. So it's always \. It's the one that's right under backspace. Oh, I forgot one. If you want to put a quotation mark as part of your string, well, obviously Java uses quotation marks to begin and end strings. So if I want to say hello everybody in all quotes, I can't just put a quotation mark because Java is going to think he's ending the string. You can see the color changes there. So how do I add a quotation mark? / quote allows me to actually add a quotation mark inside of a string. And it is so basically / and end as a new line, \t, tabs over, / quote, puts a quotation in there, \/ adds a \. So you're going to learn about those. Those are some of those special characters in there. And then you learn about what's called concatenating strings. And it's just a fancy word for like adding two strings together with a +. It's relatively straightforward here. What did I just do? Okay. Let me give an example. Let's say I've got a string first name. Let's say that's my first name. Let's say I've got a string last name. That's my last name. Some of you have seen this if you've been, talking with me or watching the meetings that we have. If I want to add these together into a full name, I can say the name of my variable. Maybe I want a space in between them, and then last name, something like that. And anytime you put a + with strings, it's just going to keep adding the strings together. So now if I go ahead and print out the full name here, you'll see that it has my full name with a space in the middle. So that the process of concatenating strings is just putting a plus sign and essentially slaps the two strings together. I put a space in there so that would have a space and look nice. If I don't concatenate a space in the middle, it really will just slap the first and last name together. And so you can concatenate as many strings together as you want to. And it's just, kind of helpful for formatting and coming up with solutions to some of these problems that make stuff easy. So you can see here, I've got a variable name, I've got a string literal inside of quotes, and I have another variable name. Technically, you could do it with ints as well. Num feet, maybe something like that. Let's say there's 5 feet. I could do something like this. Num feet in inches is, and then I could do num feet times 12. I'll put that inside parentheses so it evaluates this first. This is an int times an int, so I'll get back an int, and then it'll be num feet in inches is and then I should put on the units here at the very end. Sorry, something like that maybe. So 5. I should put feet there, huh? 5 feet. There we go. So you can concatenate strings, ints, doubles, whatever, but when you put a plus sign between a string and anything, it'll give you back a string where those are slapped together. So here it's 5 feet in inches is, and then it does this calculation over here. So that's concatenating. It's just slapping two strings together to come up with a result, essentially. And you could either print it out, or I could have done something like, I don't know, string result equals, and then on a following line I could go ahead and print out the result, something like this here. So that's string concatenation, just slapping together strings using the plus sign to create a new resultant string. I think that's it for 2.5, 2.6, and 2.7. I'll wrap it up here. If you got questions, throw them in the chat for me. 2.5, again, calling a void method. Essentially, you're sending values to the method. When you're doing that, make sure you look at the method header to figure out the order and what they represent. If it's this method header, for example, I know the name of the method is print third leg. It needs a double, and a Boolean. So I have to send in that order a double, and a Boolean. In 2.6, you're looking at methods that give back values. So there's this new thing called a return statement. You'll also see that the method header is a little bit different now. It actually has a type there. It could be double, it could be Boolean, it could be int, and you'll have a statement inside of the method that actually returns that value. What you do with it is up to you. It depends on the program. You might print out the value that gets returned. You might store it inside of a variable like you see down here. But you actually need to do something with that value now. And then lastly, in 2.7, you're dealing with strings. You're basically looking at what is a string, escape characters, and then slapping two strings together, which we call concatenating. It's just like addition. Questions in chat? How's everybody doing? Doing all right? Doing all right, good. I truly hope everybody's doing okay. If you talk to any of your friends that are in here, they're participating in CodeHS. We actually have a lot of people doing what they need to be doing, so that's great. But I'd love to see more people in these meetings. It's just, I just miss teaching. I miss seeing folks and doing this thing. So if you talk to them, say, hey, join Mr. Foster. I am going to have another meeting on Wednesday. What time did I say? Wednesday at, oh my gosh, get your life together. Wednesday at 11 a.m. So if anybody has questions, I'll have an open Zoom meeting Wednesday at 11 a.m. Pop in, say hi. You can shoot me an email always. My email's right there. Make sure you don't email Mr. Lucas Foster at the middle school. He probably can't help you with computer science, although I've heard he's a brilliant teacher. Maybe he can. Maybe he'd help you more than I can. Who knows? And then lastly, I've got my schedule there if you want to book some one-on-one time. you can go to that schedule and book some one-on-one time, which some of you already have, and then we can share our screens and work. It's just like we're working on them together, and I'm totally fine with that. So any of those things are totally cool. Make sure you contact me if you have questions. Don't suffer in silence. Keep up the good work. Since I don't see any questions in chat, I'm going to take off and end the meeting. So nice to see you people. So nice talking to you. We'll do this again next week. We'll do a meeting on Wednesday at 11, and hopefully I'll see you folks then. Bye, everybody. Very welcome.
See you, Mr. Foster.
See ya. Thanks for joining.